Hi, everybody, and welcome today to our monthly SICSA Educators Seminar. My name is Dr. Emilia Sobolewska, and I am a SICSA Educational Champion for School of Computing, Engineering and Built Environment. And today I have a huge pleasure to introduce my colleague and partner in crime, Carl Strathearn, who is going to be talking about his experience with working on rapid technology assessment with UK government. Carl is a lecturer and researcher here at Edinburgh Napier University. He predominantly works with AI and humanoid robots, and you might know him and his companion Euclid as a very well acclaimed and one-of-a-kind, most advanced currently humanoid robot produced by universities. And I'm not going to take too much of your time. Instead, I'm going to ask Carl to join us and start his presentation.
Thank you. Thank you, Emilia, for that introduction, and thank you for organising this, and Chrissy as well, and everyone here and everyone online. So I'm going to try and share my screen. Hopefully it will work. Okay, this is a talk in three parts. The first part, I'm going to give an introduction to humanoid robots and talk about the lost history, because there's a little bit of confusion around humanoid robots. And then I'm going to talk about the rapid technology assessments, because who knows, one of you may be asked one day to do one of these, and it's good to know the process, because I didn't know the process. And it was kind of an interesting learning curve. And then I'm going to talk about the outcomes of that. And then I'm going to give my insights into what I think humanoid robots should be used for in education, because it's slightly different from what was in these reports. Also, for those online, everything I refer to will be on my website. So rather than including hyperlinks into stuff, if you want to go on my website or use the QR code, all the videos, everything I refer to is on there for reference. Okay, so the UK actually has a lost history when it comes to humanoid robots. We created the first actual physical working humanoid robot called Eric in 1928. And it often gets overshadowed because sort of a year earlier was when Fritz Lang's Metropolis came out. And that was a film, but we actually created a working robot that could stand and talk. And then not only that, we created the second as well with Alpha, and Alpha was able to read the paper. They recorded his speech, and he would sit and he would read the paper. Now, I say this is kind of a lost history because it's not like these are not known and they're not in the public domain, but a couple of years later in 1938, the Americans created Electro. And they took it quite seriously as a scientific robot, and they took it out and they had it at the World's Fair. We created sideshows, right? We took these around towns and we, had people interact and engage with them, but they weren't considered as scientific value at any point. But the Americans took it quite seriously. So people often mistake Electro as being the first humanoid robot, when actually we created the first two in the UK. Not only did we create the first two in kind of engineering terms, we also created the first one in academia. We actually created Able Mabel, who was a kind of a telemetric robot, but it would do things like it had a coffee machine in it, and it would go around and it would serve people coffee. And this is 1966. Again, people make the mistake and they get confused. Well, let's say they get confused, but they take the first robot in academia to actually come from the University of Wakita in Japan in 1973, I believe. So again, we have this lost history. We actually have a heritage of humanoid robotics, but it's very rarely discussed. I think it's really important to kind of verify that we started this stuff. We started building these things, right? And we should have some claim over it. We should claim this back as ours, because these are three robots that are always overlooked. So one of the questions I always get asked is, why humanoid robots? Why do we need them? So the most natural emulated interface for human communication, recognizable features, expressions, emotions, and gestures, etc. Now, we're all very fortunate. Whether you're online or in this room, we're very fortunate. We all use technology. We all have computers. We have access to AI. But humanoid robots, lifelike humanoid robots, are actually a real accessible and tangible way to use advanced AI systems naturally. If you've never used a computer before, or There are certain instances in healthcare where people can't use computers or have never used a computer in their life. These robots have shown to actually be a very useful interface because they're recognizable, natural. And if we can emulate that, then we can allow those people to utilize the most advanced AI systems effectively. And I think that's a really good use case. From an education perspective, they're a tangible and accessible way to learn core AI and STEM skills. Now, so we've been doing experiments with these robots called robots, and they're kind of these little plastic blue robots, but they're great for learning kind of these key STEM skills because you can build a robot mouth and learn about natural language processing. You can create robot eyes and put them together and learn about computer vision. So it's a way of grounding everything, right? It makes it more accessible. And when you're dealing with young children and people coming to the learning this for the first time, it's really useful to actually have that grounding. And going on to that, like I say, it grounds AI in the physical world, unlike disembodied systems like Alexa. Now, I was reading a study about Alexas in care homes, and they were saying that people in these care homes, when they left the care home and they put Alexa in them, were still talking to Alexa because it's a disembodied voice. So they didn't make that connection between interacting with the robot in the care home and when they left the care home, they were still talking to Alexa. And whereas robots are grounded and they give you that grounding. Whether or not I think they should be used in healthcare is a different thing we'll discuss later, but I think that's one of the uses and potential uses. One of the main things is they're designed to use our existing human tools, so we don't need to design bespoke robot tools. And this is really important because a lot of very specific niche bespoke robots have to have bespoke tools for them. We don't really want that. We want robots to be able to come into our environments and use our tools, right? And that requires a training, right, to use those specific tools rather than designing tools to use. And like I said, multi-purpose by design, one robot for many tasks across many different domains rather than multiple single-purpose machines. So the idea of, example, a robot working in a kitchen, you would want it to be able to use all those existing tools rather than have specific tools for each of those tasks. That's the idea. Okay, so now we can talk a little about the Go reports. So I was emailed, and this is kind of the process of what happened. I was sent an email and went for an interview. Essentially, they wanted to know my background and skills. And when we got talking, the questions were kind of, what robots do you know? What domains, what fields are they applied in? And they asked me a lot about the industry, like, do you have connections with industry? Do you work with industry? But then I got on to talking about kind of my passion, like my side projects, what I do at home, like building robots in my spare time. And that became the focus of the conversation. And for those that don't know, like 20 years ago, I started building robots in my bedroom, and 20 years later, I'm still building robots in my bedroom. Right? The technology has changed drastically over that time. When I first started, everything was hand molding and had to be vacuum formed. And 3D printing came along, rapid prototyping, and everything just became so much easier to do. And when I was doing my PhD, I had to build these robots. I built them out of necessity because I created gelatin eyes that could dilate to light and motion. I created the first example of machine learning algorithm for robotic lip synchronization. Without building a robot to install these components, I would not be able to test them. And the nice thing about that is I have PhD students now who are using those robots for their work. So it's like come full circle. It's a real nice thing. And that's why I still keep building them to this day, because I'm always trying to keep up with that technology. So the purpose of these reports, okay, so I had my interview. I think it was a follow-up, actually, sorry, there was my main interview, and then there was a follow-up interview, which I assumed was a follow-up interview, but actually turned out to be an interview for another assessment, a completely different one on AI robots, and that's why I was a bit confused. I thought it was the second part of the first interview, but it wasn't. It was an interview for AI-driven robots, and this was about swarm robots, vacuum cleaners, agriculture robots, and stuff like that. So that was a little bit more formal, a little bit different to the first one. But then I started receiving things to review. And they essentially had an overview of robots, commercial robots, and they want to determine what these systems could do and what domains they could be used in, and rough ideas of costs and things. And that was the first thing. And then there was a process of it was like any kind of review, like when you review a paper for a conference or a journal, when you're a reviewer, you kind of review it up to the final form is completed. But As I say here, the robots I was asked to review was the Unitree H1, the Tesla Optimus, Boston Dynamics Atlas, the Apollo, Figure 1, Digit, Amica, and Cyber 1. And each one of these came with a specification. Now, I asked where that specification came from, and they wouldn't tell me. So I don't know where that information came from, but I assume it was official information because it was in the official form. But that was true for most of this. There wasn't actually, if any, references to where this information was coming from. I assume it was all done in-house and collected, and it was just my job to review it. So the first part was to evaluate, and then it says the offset between manufacturing and production time, current and predicted investment rates, and expected returns. So there's lots on there to do with marketing, right, and factors such as demand, access to technology, and how that would be predicted over the next 5 years, because these reports essentially predictions for the next 5 years, from 2024 to 2025, the next 5 years. So that's what that was about. But this is what I'm saying here. It was an interesting thing because I was looking back at the reports the other day, and I thought, I wonder how many new robots have been brought out since that report was written. I mean, it's only a year and a bit old, and there were tons that would absolutely replace nearly every robot in that list. But maybe the Optimus and the Atlas, but that's how fast this has moved on. This shouldn't be a 5-year report, but everything's already changed within a year, and it's changed drastically. And you can't predict this technology. So my job was from points 1 and 2, suggest which fields that the above robots could be applied in now, and from predictions for the next, from point 3, make predictions for the next sort of 15, 20 years, but the focus on the next 5 years, and for the RTA reports. So these were kind of the key findings, and they were all rated like this. It was high, low, moderate. So the application, it says, over the next 5 years, leading companies are likely to focus on commercialization in sectors such as manufacturing and logistics, where operating environments are more controlled. And this is vitally important to understand. We're seeing robots leaving the labs and going into factories. They are doing the jobs of existing machines in those factories. We already had machines that could do the jobs that these robots are doing. But those environments are extremely controlled. Right, we can train a robot in a lab that emulates the environment of a factory, and we can do that rather well. Put it into somebody's home is a completely different kettle of fish, because that's an incredibly complex environments interacting with humans. In a factory, you'd expect a robot to do repetitive tasks, much like we already have existing machines for. In terms of investment, the pace of humanoid robot development is accelerating due to increased investment and advances in enabling technologies. And we're seeing that. We're at a point now where the UK has its own startup venture called Humanoid, and they are taking off. So we're even seeing in the UK companies starting to set up now, major companies, and going international. We're seeing other companies around the world starting up all the time. I kind of do a lot of work in industry, kind of advising, and especially these kind of up-and-coming Kickstarter project kind of things, and that level is enormous at the moment. Okay, because this technology has become so easy to build and create, and people are making their own versions of it. In fact, there's a company that has just created the first fully 3D printable humanoid robot that you can print at home, walking, fully able to run the latest models. So that's where the technology is sitting. So the first part of this kind of report was to determine the current state of technology. So it says humanoid robots continue to face significant technological limitations, and their future impact remains highly uncertain without substantial advances in critical capabilities such as dexterity, autonomy, and power systems, and applications that are likely to remain confined to structured and controlled environments. So here we see this rhetoric going back. These robots are great, they can do all this, but in controlled environments. Now, again, this is why they're in factories and they're not in people's homes. Also, a really important thing to understand is that these systems can't be run for a long time. If you have a robot in a factory, it can't be run for a few hours. In terms of the battery power, these things use a hell of a lot of battery power, unless you're plugged in all the time. But even then, you're going to have overheating servers and things. So the idea of actually replacing people to do a full day's job or a full week's job with a robot like this is improbable, just because these systems need time to cool down. And the next part of this was to figure out where the technology would be in the next 5 years. So if highly capable humanoid robots would emerge, they would likely have significant societal, economic and strategic implications for the UK. The deployment could create substantial productivity gains across sectors such as manufacturing, logistics and health and social care. Really? I don't think they do. And this is where I kind of separated from a lot of what was said in these reports. And to be absolutely honest with you, I felt like they were playing the Lord of the Numbers, because there's about 15 other people reviewing these papers as well. I think if you say something specific and not everyone else picks up on it, they go, right, that's one person's opinion, let's leave it, because that wasn't my agreement at all. But we had some key technical challenges as well to look at. So these were the outcomes of those. So the compute to reduce reliance on connectivity and cloud processing, and that's a real big thing. The robots we use in the university that my PhD student Lewis has been creating AI systems for, all run offline. They're offline because it gives you protection and privacy over that data. So it's all stored on that computer. No one else can access it on the cloud. But also it's about connectivity. We can take that robot and put it anywhere, right? We can take it to events. We've taken it all around the world, as far as Geneva, and not had a problem because we're not relying on cloud networks. So autonomy and adaptability, the new use cases and environments. And this is really important because even though we're going to take a robot, we're going to say it's a general robot. We want to do lots of things, lots of tasks like a human. Most of them are not adaptable physically in any way or form because they're commercial robots. And I think there's great value in people building their own robots and testing them out rather than buying them just for that specific use case. So obviously reliance, the need for operational maintenance, and some of us here know that when something breaks in robotics, it takes a long time to get repaired and it's very expensive. Dexterity, precise manipulation, and this is the problem. I'm going to go into this a little bit later on when I talk about vision language action models. The precision of this technology isn't that great, okay, but it's something that we need to have precise for it to be able to work in the environments we want it to work in. So I would say if you have a complex task, the best thing to do is not come up with a complex solution for it. You have to have a simple solution, and from that build up to the complexity. And that's, I don't think VLAs are fully there yet because of that. Power and energy efficiency, like I said, battery, weight, size, and runtime are always an issue. Speed, obviously keeping up with human speed. A lot of things we create ergonomically, we create because we think humans are going to take that long to use them or have that sort of handling of them. If you have a robot going incredibly slow, you lose some of that ergonomics. Obviously, mobility as well. I would say if a robot falls on you, then what? But being able to operate within our environments, that's the key thing. Getting robots to climb stairs, for example, is still an unsolved task. So these kind of other findings, okay, and I kind of summarised them that I want to talk about. So I said the average cost of a humanoid robot is between £40,000 and £150,000 for a single humanoid robot. I don't agree with that. I couldn't find one for £40,000 in the current market. And I keep an eye on things. So that's something I think has slightly shifted. I think since then that price has increased. But it says the UK is first globally for research quality in the field citation ratio. And the UK ranks 7th overall by volume of humanoid publications. And this is kind of great, right? Because as I said, we have this heritage of humanoid robots. And we're also conducting, research in this area still, but it's about knowing this information. Now, an interesting thing produced by Go Science was this chart. And it was challenges and time and uncertainty. You can kind of imagine it like a time complexity. We're talking kind of bigger. They said that the most likely, easy challenge and within the time is hospitality. I don't agree with that. So here's a couple of hospitality robots. I'm sure some of you have seen these videos online. One smashes up a customer's table and they can't stop it, and it just has to be kind of wheeled off. And the other one is they created a robot vending machine. So you have a robot and you type in what you want, it goes to get what you want. And we already have robots for them called vending machines. So we'd actually need a robot vending machine because we already have a robot vending machine called vending machines. These kind of uses of robots, I don't think what we should be aiming for at all. I think they're more gimmicks. I don't know how people feel about that, but I know we have robots that can serve food, but that wasn't a robot that could say food. It wasn't a humanoid robot, is what I consider a humanoid robot to be. You know, the ones you see with plates on their head and they kind of drive around, they're more like robot vacuum cleaners with a stand on the top. So yeah, and the interesting thing about this is education. If you see education on the chart, it says the challenge is really low. I don't know why. How is that a low? How is education a low challenge to put these robots in? I never got any clarity on that. But all I can assume is that they were thinking of a robot as being a stationary object that we could just use a large language model and talk to people, rather than an interactive moving around robot. Because like we see in the example of the restaurant robot, you don't want that one going around and, you know, hitting students on the head or anything. So that's really important. And one of the interesting things about this diagram is where you see healthcare in terms of the challenges and the time. And again, this is really interesting because we're seeing a lot of research at the moment within the healthcare domain. And I always think how difficult it would be to put a robot in healthcare. I think there are very specific use cases for it, Casper being one. So Casper is a robot designed for children with autism. It's designed for that specific use case. But we aren't considering specific use cases here. We're talking about whole fields. That's very different. Would you want a robot in a hospital? Well, could a robot work in a hospital? No. And there's a lot of studies at the moment trying to force this agenda almost. And I don't agree with it because I don't think that actually matches up with the reality of the situation. So that is one thing I did agree with in that as well. And also there was these graphs. So this a graph of the projections, and you can see that the humanoid market is, like I said, it's increasing all the time, and we're in this kind of boom. Now, whether that bubble will pop, I'm not sure, because we seem to have a lot of misinformation in my field where, especially from the industry, who put out videos as evidence of a robot's capability. And a lot of them are CGI enhanced, or they're manipulated in some way. And that's not a true representation of the capabilities of that robot. We need industry to start doing peer-reviewed scientific reports on their robots. Right, and then we all know, we can say, right, yes, we can all agree that this robot can, I don't know, do anything other than dancing and kickboxing and, you know, these stereotypical kind of things you see robots doing that are actually all useless. You don't actually ever see robots kind of walking upstairs in someone's home or, you know, doing something useful in any of these videos. It's all very carefully choreographed, and it tends to be more, you know, displays of dexterity rather than actually doing anything useful. So yeah, that's why I kind of sit with that. So after this report was published, Go Science actually started doing a study. They went into primary schools in Oxfordshire, Buckinghamshire, Leicestershire and Nottinghamshire. Obviously a really wide population sample there represented, accessible, considering everyone from all backgrounds. No way was this bias in any way, shape or form, and just year 5 and 6 children. Again, you know, nothing wrong with this sample at all, was brush over. But yeah, you put in an actual robot in any of other school, like let's say a normal state school, I think would have a very different experience being put in a private school in any of these schools as well. So I think there was no results published from that pilot. So I imagine it was never taken on any further, but it's just interesting, right? That with this technology, we safeguard it so much. At the same time, we want it to be out there in the world doing things. But how can we if we're just going to safeguard it? We're just going to say we're going to only allow certain people to use it, certain groups of people, you know, and that's not something I agree with. Okay, so this is kind of into my perspectives now, okay, and what I think robots should be used for in education, because I think there is a place for them, but not as teachers. Okay, we don't need robot teachers, so don't be worried about losing, you know, your jobs or anything. So robots are a real tangible way to learn core AI and STEM skills, like I said, and as a teaching tool, they are fantastic. So this is my PhD student Miyoku's work, who's currently working in large language models for our realistic humanoid robot Euclid. And because he's an old robot, he has a very specific personality. And he wants some adaptability into that. So for those of you online here that don't know what a large language model is and how it works, I'm going to explain it to you using Searle's Chinese room experiment example. So in Searle's Chinese room, a participant is given a bunch of Chinese symbols, and they're scattered randomly along a floor. And he is given an instruction manual of how to organize these symbols, okay, to make sentences. So he does that, and he keeps doing it, and day after day, he gets proficient at it, and they take away the instructions. A bunch of Chinese linguistics who are fluent and can understand the writing come in, and they watch him arrange the symbols, and they have to judge if that person understands Chinese language or not. And they all said he did. Now, the fact is that person didn't understand what was said in these symbols. They didn't understand it could have been a poem. It could have been a news report. They didn't know. They just knew the order, right? They knew the order. So this is where the phrase syntax is not semantics comes from. Okay, being able to order things within a certain structure is not actually understanding. Okay, with large language models, we have to give them context. That's what we have prompts for. We give them context, and from that context, they generate, right? And they generate from a knowledge base, but that's all they do. They just generate sentences. So this is Miyoku's project, and it's actually a real nice thing for my students to be using the robot I built for my PhD work, but also she's taken it in a really interesting direction where she's using multiple intelligence theorem and actually modeling different intelligence types using Euclid and using different models. But again, we couldn't really do that without having Euclid. You know, we needed Euclid as kind of a platform for this because he's open source and usable. So building robots in this instant, I think, is really important, and it allows our students and PhD students to do this advanced research. And we also have Lewis's PhD research. So if any of you have seen the recent video of Moira online, what you can do with Moira is you can ask her to, you can say, what do you see? And she will look around the room and she will tell you what she can see. And this is a visual language action model. So like a large language model, you can imagine now we have a vision section above it. And what that vision part does is pass classifications down, right? It tells you what objects it can see, it classifies them and passes them to the large language model. And that formulates those classifications, those objects, to make a coherent sentence with. So we took Moira, this robot, to the HRI conference, and it was really nice to see people interact with her, but also she was describing what people were wearing. So people would say, you know, tell me what I'm wearing. And she would describe to what they wear, down to what was written on their badges. It's a really impressive piece of machinery. But again, we don't teach this stuff in universities at undergrad level. And I think we should. I think we have been teaching large language models, but we have not been teaching visual language action models. And I think that's the case for most universities. Okay, there's this disjoint between where we have knowledge-based systems and vision and language-based systems, and we're really moving into this space now with vision and language, where you can imagine the power of giving ChatGPT eyes. That's the best way I can describe it, and having that inference. Okay, and kind of finally, this is my latest work. I've been working with visual language action models. Now, this is kind of the final part of this. So we have large language models, knowledge base. We have vision and language models, which is vision and language. And now we have action models, actually encoding some actions. Now, if you can see online, I have cameras in my glasses. These are the Ray-Bans that you can record things with. So I've been trying to create a small data set to train large language models on, and it is so difficult to do. So the idea is that you record your hands doing tasks at home, and then you can train the robot or the model to basically sequence those actions, right? So when the vision's triggered, sees an object, it tries to do some semantic understanding, and that's passed to some actions of the robot actually manipulating objects and doing things. But it's really, really difficult because you have to have everything in front of you to start with. Like when I first started trying it out, I realized that I was going around the kitchen and putting all this stuff together, but all that data is useless. You need everything in front of you, right? And then if you make a mistake, then that results in an outlier. So it's what we actually find with this new technology, even though it is the latest cutting edge technology, is that there's massive loss in it. And we're actually trying to train these things, they have incredibly high loss. But that's not stopping kind of this kind of state-of-the-art moving forward. And it was 2 days ago, they released a news article where they were saying that some sweatshops in India were actually having their staff wear cameras on their heads so they could model VLAs on the tasks they were doing within the factory, and eventually hopefully train robots to do those tasks. And it's like, how unethical is this? People are basically, working themselves out their own jobs, which are not the best jobs to be in the first place with the conditions. So that is just a really major ethical dilemma we have. But at the same time, we have such a data shortage with VLAs. My suggestion, I did an article, actually, this article I did in the conversation, and I wrote it about Elon Musk. Now, I have a bit of an up and down relationship with Elon Musk. The first article I wrote was from BuzzFeed, and he commented on it saying he hated BuzzFeed with the power of 1,000 suns after reading the article. So obviously that blew up and became quite a nice article. But then in the conversation, I picked it up again. And we ended up having to go through lawyers' fees, which cost more than the publication fees because everyone was worried about Elon Musk suing them over this article. But essentially, in that article, sort of saying that, would you really want one of these robots in your home? And what would happen if something went wrong? VLAs, like any other system, cannot detect when something goes wrong. It's just going to keep working. You could get trapped in that mechanism, and it's not going to know. Right? There's no kind of fail-safes. Maybe there are fail-safes on the robot, but not in the model itself. So that's obviously another issue with this. But those are all negatives. So I'm going to give you the advantages of these systems and why I think they are important when they're used correctly. Because they can be generalized. So the tasks we teach the robots to do, picking up objects and doing things, they can be generalized. So you can teach it to maybe pick up a cup and it will learn to pick up other objects in the same way, providing the classifications match, let's say, in the language. So that's really useful because this is the first time in robotics where we're seeing robots having that additional adaptability. And that's really exciting to be in. But again, it has to be controlled, it has to be done in the same way as all the other testing we do. Now, let's say visual language models, essentially all you're doing is just that extra layer of encoding is just tasks, right? And movement of objects. But one of the things I'm wanting to do, and this is the robot I've built to do with, is to do that with facial expressions as well. Because that's something that's kind of left out. Facial expressions are an action, okay, not just object manipulation. And I think that's a really interesting area to explore with VLAs as well. But again, I feel like we should be teaching this. It's another thing we don't teach in universities, but again, we don't have the technology to teach it. And we can teach VLAs if we had a robot arm, or if we had something as basically a robot arm, or something as complex as a state-of-the-art humanoid robot. But we don't have them. So again, this is kind of the emphasis of we should be building robots to test this stuff out. It's not that hard to do. We now live in a time where it's never been easy for people to build robots. All these systems tend to come with AI enhancements where you can use AI to help you write code, help you do the modeling, help you do the probe. Like everything can be, AI can be used to help facilitate this. So I think anyone interested in doing this is the time to start doing it. Because it's never been easier, especially when I first started and I was pulling my Xbox connector apart and stuff to get components out of it. Okay, so to wrap up, my final thoughts. So the IT reports probably have a shorter lifespan than 5 years due to the rate of growth and technological advancements using the given robots as baselines. So like I say, it's just moving all the time. And I believe Scotland could be the future epicenter of robotics. I don't say that lightly. I don't throw that out there lightly. But the fact is we have such good infrastructure. It just doesn't have adaptability. It's the same in education. We have good singular kind of schools and things, but ideally everything should be multidisciplinary, everything should be adaptable and work together. We have industry working on bearings for specific things. Well, bearings could be used for robots. We have like all these individual things. We have energy and power, but these could be used for robots. We just need that a little bit of adaptability, coming together and say, oh, we could just make a slight adaptation to this and it could be used in robots. And I think that's the way forward for Scotland in the future is we have that infrastructure. We have most of the things we need. We just need that adaptability. So we should be using robots as educational tools instead of for teaching and AI, not as teachers or teaching assistants due to the risks discussed. And yeah, I still don't know why in those reports it said that it was so easy to have a humanoid robot as a teacher. If anyone has a conversation after that or else has a question, that's a great topic to start with because I don't know. So this is another thing I want to talk about and why we should be teaching large language models, visual language models and VLAs in schools, universities, because these are now the things that are required in job specs. Matching graduates up now to these job specs is almost impossible. I'd say graduates leaving now have 40% of the requirements on those job specs. The other 60% they have to do in their own time. And I've known students to do courses to try and apply for jobs, and that's just not fair, right? But it needs to be some changes, and we need to keep up with these latest developments, because these are now requirements. I find that what once was requirements sort of 10 years ago, and now we're just expected. You don't even see them listed on the, on the thing. It's just, this is expected. Basic engineering knowledge, mathematics, this is expected. You're not going to see that on the job spec. So that's why I think we should be teaching it. And finally, as I say, without a solid foundation in education, the UK robotics industry is not sustainable long term. And I don't think it is. I think if the bubble's going to pop, that's why it's going to pop, because we just can't fill those positions. There are so many positions that are open, and they're open for many months, and they just keep trying to find the right people for it. But we have that disconnect between industry and academia. And we need to kind of strengthen that. We need more communication between the two. And, when you send say a master's student off on a placement, they still have to do a dissertation. They still have to do work during that time, and they're not going to learn everything they need to learn. So we really need to step up our game, I think, and start teaching these core models and core approaches that we need in humanoid robotics. And that's it. That's my final thought. So thank you, everybody. I'm here to take questions. If you have any questions.